Okay, so we're going to talk about trig functions of real numbers. So we're going to use the x and y values from a point. That is our terminal point on the unit circle, and it'll be determined by t. So understand that your sine values go with y. So sine, sounds like y, goes with y, and cosine will go with x. So if we're looking at these are the functions that go with. So sine goes with cosecant. It's going to be the reciprocal, so it'll be 1 over y. Of course, y can't be equal to 0, or it's undefined. Cosine goes with x, and the secant, so we have sine and cosecant. Cosecant goes with the reciprocal. Cosine is x. Secant is 1 over x. Of course, x can't be 0. We have the tangent of t, which is y over x, and cotangent is x over y. So when we're looking at these, understand that every pair of these gets a co. Sine has cosecant, cosine has secant, and tangent has cotangent. Well, tangent and cotangent are the easy ones, but these are the ones that people mess up all the time. So do be aware that it's going to be, if it's cosine, it'll be secant. If it's sine, it's cosecant. And then think about tangent. It's y over x, so it's sine. So the n for tangent means the sine with the n is on top and then over cosine. And cotangent will have our cosine over our sine, which is our x over our y. That might be some helpful hints to help you figure that out. Remember that when we're moving a positive distance for our t, it's going to go counterclockwise. And if we have a negative t, it will go this way. It'll go clockwise. So we're going to find, these are our 6 trig functions of a terminal point. So we want to find, pop back up here, find the 6 trig functions of each given real number of t. So if we're looking at t is equal to pi over 3, so that means we're going 1/3 of the way towards our pi. So understand, let's look at our unit circle here. Pi over 3, remember we're already starting here at this point where we're at 0 and it's on the x-axis. We're going to go up to pi over 3. We talked last time that if it's pi over 3, 3 would be in the number of the second part of our point. So this is the terminal point. Remember I told you you're going to need to know these points on our unit circle. You can find the rest of the points. Go watch the unit circle video. You can find the rest of them if you know quadrant 1. The more that you know and understand these, the easier all of the math will be. If you get them wrong and you reverse them, especially these two here, then it's going to cause you all kinds of issues. So make sure you understand how they're going. So here we have 1/2 square root of 3 over 2. So that's our terminal point. And we're going to use that to find all of our trig functions. So the first function we're looking for will be sine. And the sine of pi over 3, remember that's equal to our y value. This is our x, this is our y. So it'll be the square root of 3 over 2. Cosine for the pi over 3 would be equal to the x value, so it's equal to 1/2. So let's go find the reciprocals of these. Recall that we just talked about sine will get a co-companion in there, so it'll be cosecant of pi over 3, and it's equal to the reciprocal of our y value. Now, we don't divide by fractions, we multiply by reciprocals. So this would be equal to our multiplying by that reciprocal, it'll become 2 over the square root of 3. So if we reciprocate that, multiply it by 1, it just becomes that. Now, we don't want to have a radical in the denominator, so we multiply by whatever the 1 needs to be. So it's usually just by that radical on the bottom. So we get 2 square roots of 3, and square root of 3 times the square root of 3 would get you square root of 9. Square root of 9 is 3. Or understand, whenever you multiply these, you're going to get, if they're exactly the same, you'll get what was inside. All right, so that's our cosecant. So cosine goes with secant of pi over 3. So the secant of pi over 3 will be the reciprocal of our x value. Again, you don't divide by fractions, you multiply by reciprocals. So when we multiply by 2, it'll just be 2. Now we're going to go do tangent of pi over 3. Well, remember, the tangent is going to be the y over the x. So we'll have the square root of 3 over 2 divided by 1/2. Again, we don't divide by fractions, we multiply by reciprocals. So square root of 3 over 2 times 2 over 1. Our 2's will cancel, and we'll end up with the square root of 3. So here's 1, 2, 3, 4, and 5. We need one more. We've got cotangent of pi over 3 would be equal to x over y, which is 1/2 divided by the square root of 3 over 2. So 1/2 times 2 over the square root of 3. The 2's will cancel again, and we end up with 1 over the square root of 3. But we can't have that square root in the denominator, so square root of 3 over the square root of 3. That gets a square root of 3 over 3, because that's what we'll get in that denominator. So those are our 6 trig functions of our real number t at pi over 3. All right, let's go do another one. So let's do t is equal to pi over 2. So we need our terminal point, and when we're talking about pi over 2, that puts us at half a pi, which is our y-intercept. So our terminal point will be 0, 1. All right, so again, we need our sine. The sine of pi over 2 is going to be, here's our x, here's our y. It's equal to y, so it'll be 1. The cosine of pi over 2 is equal to our x value, which is equal to 0. So our cosecant of pi over 2 is 1 over y, which will be 1 over 1, which is still 1. Our secant of pi over 2, which is equal to 1 over x, would be 1 over 0, and that will be undefined. Can't divide by 0. All right, now we've got 4 of our values. So now we need our tangent of pi over 2, which is equal to y over x. So that will be 1 divided by 0, which is going to be undefined. And then we need our cotangent of pi over 2, which is x over y, which is 0 over 1, which is equal to 0. All right, so there's some special values of our trig functions. So I've got a couple of things on here. First of all, you can easily remember the sines and cosines of the basic angles by writing them in the form of the square root over 2. So let's push this down a little bit. I think it comes in a little better. So for 0, it's square root of 0 over 2. Pi over 6 is square root of 1 over 2. We talked a little bit about this last time. Square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Where square root of 4 is 2. 2 over 2 gets you the 1 that's at your y-intercept up there. And then for cosine, it starts out at square root of 4 over 2, square root of 3, square root of 2, square root of 1, and square root of 0 over 2. So we talked last time it went from 0 to 4, and then it goes from 0 to 4 this way. So for the x values, it goes from 0 to 4, and for the y values, it's going from 4 down to, from 4 down to 0. So just be aware of how you can find these yourself. So I think I said that backwards. So at 0, we're at the 4 for the x, so 4 up to 0, and the y values will go 4 down to 0. So they're kind of opposite. We also have some special values of the trig functions. So this is your trig functions in quadrant 1. It's where it's all mapped out here. So we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. Those are the values that we know in our unit circle. And these are the values of all of the functions. So we've got our sine, cosine, tangent, cosecant, secant, and cotangent. You do not have to know these. What you need to know is what the values are for the terminal points. And if you know the terminal point, you can find all of these. So, and these are just our x and y's up here to use for that. All right. And remember that not all of our functions are there. Some of them are going to be undefined. Now, sine and cosine will be defined for all values because we don't see any undefined here because they don't have that fraction. So you can't divide by 0. Some of these you'll see when sine is 0, cosecant and cotangent will be undefined. And when you have 0 for your cosine, then tangent and secant are undefined because that's when our x values are in the denominator. All right. And those happen at our certain increments. So if we look at where those happen, so for cosecant, that's when t is equal to 0. So that's when we're at the point right here. And it would also happen over, oops, let's zoom out a little bit. So it'll happen at this and this. That's when y equals 0. So it's going to be for every time you're at pi, 2 pi, 3 pi, 4 pi, all of the pi's will be undefined at our cosecant. And also for our cotangents, because that's when y is 0. Now, for the tangent and secant, that's when our x is 0, and that's going to be at the top and at the bottom of our unit circle. So it's always going to be at pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 7 pi over 2, so the odd pi's, 1, 3, 5, 7, and so forth. So just a little bit to make sure you're becoming aware of how our functions are working. All righty. Let's see what else we've got going on here. So we've got the domains here, the domains of the trig functions. Understand that the light is not flowing well with the paper here. So when we're looking at our function with the domain, the sine and cosine are all real numbers, and tangent and secant are all real numbers other than, remember I talked about the pi over 2 part for any integer n, and cotangent and cosecant are all real numbers other than n pi for any integer n. So as long as you're doing okay with those and you understand where they're going to be undefined, that will help you out a little bit. And so you know kind of what's going on. The more you understand and can connect with that unit circle, the easier it is going to be. Alrighty. So the next thing we're going to talk about is how some of our signs are on our handout here. So we have the signs of the trigonometric functions in the quadrants, what's going on with them. So that's, again, looking at what's happening. All of them are going to be positive, and none of them will be negative in quadrant 1, because that is, remember, where our x and our y are all positive. Sine and cosecant will be positive in quadrant 2 because those deal with the y-axis, so quadrant 2 is over here. This is positive. And our sine, cosecant, cosine, and secant, cosine, secant, tangent, and cotangent will all be negative because they have an x in them. This is x, this is 1 over x, this has got x and y in them both. So those will be negative because they have an x in them. Now down in quadrant 3, most of them will be negative, but the tangent and cotangent will be positive because they have 2 negatives in them because they have the x and the y value, and the rest are negative. So tangent and cotangent will be positive here and up in quadrant 1. And then over here, we will have our cosine and our secant because it has a positive x. They will be positive and the rest will be negative. So again, making those connections with your unit circle will help you out. One of the things you can do to remember them is a mnemonic that all students take calculus. Not all students do, but you can use that. So all sine, tangent, and cosine. That tells you what's positive in what quadrants. So we can easily figure out what's going on and where things lie. And what the sign will be by knowing where things land in there. All right, so we're going to look at a point and then be able to figure out. So if I give you t is equal to 2 pi over 3, we can figure out what quadrant it lies in. Now 2 pi, remember that's about 2/3 of the pi, right? So pi gets you clear over, and I know this has the answer on it, but let's just talk about it. So pi is halfway around. This would be 1/3, and then 2/3, 3/3. So getting a feel for where it's going to land. 2 pi over 3 will land in our quadrant 2. So because it lies in quadrant 2, we know that cosine of 2 pi over 3 will be negative. Now if we're looking at t is equal to 4, remember halfway around is 3.14, and then the rest would get us to 6.28. So we have to kind of get an idea of where does tangent of 4 lying in. What quadrant will that be in? So that's going to, if we kind of do the math like we did last time, we'll find that 4 lands in quadrant 3. So if we're looking at t is equal to 4, it lies in quadrant 3. So the cosine of 2 pi over 3, oops, sorry, not cosine, sorry, looking at my notes wrong. So the tangent of 4 is going to be, if it's in quadrant 3, tangent is going to be positive. And they may refer to that as like greater than 0 and less than 0 if you're looking in some of the homework. So let's go evaluate some trig functions. So with that, we're going to find some reference numbers. We're going to use our reference number. If you remember, we did those last time. So remember, the reference number is how close we are to the closest x-axis is what we're looking for the reference number. So if we're looking at cosine of 2 pi over 3, remember that our reference number is taking the closest x-axis, so 2 pi over 3, we got to go clear down to pi. So if we took our pi minus our 2 pi over 3, got to have that common denominator, so we can make it 3 pi over 3, and that gets us pi over 3. And the terminal point then, this terminal point would be in quadrant 2, so we are in quadrant 2, because that helps us know which way our signs go. So we know that the cosine is going to be negative, right? Because in quadrant 2, cosine is our x value, it will be negative. So the terminal point of that is going to be in quadrant 2, so we can thus say that the cosine of 2 pi over 3 is equal to the negative of cosine of pi over 3. And if we know our terminal point at pi over 3, the x value is 1/2, so it'll be negative 1/2. So we can do the same thing, and we're just understanding how they connect. So if we do tangent of negative pi over 3, remember that negative is going to go clockwise on our circle, so our reference number for this will be the same. So the reference number is pi over 3, because that's what it would take to get back up to our x value. So think about our circle. Negative pi over 3 goes this way. It'll be the same distance to get back to the x-axis. So our terminal point is going to be in quadrant 4. And in quadrant 4, our tangent is going to be negative again, because we'll have an x and we'll have a y. So it will be negative, and in that quadrant 4, we know that x is positive and y is negative. So we know that the tangent of negative pi over 3 will be equal to the negative of the tangent of pi over 3. So we're just figuring out how things relate to the one that's in the first quadrant. And tangent in pi over 3, so remember our point for pi over 3 is going to be 1/2 and the square root of 3 over 2. Now, we can use our special chart to find our tangent. So the tangent of pi over 3 is going to be square root of 3. Or we can figure it out. Remember, it's going to be our y over our x, so square root of 3 over 2, divided by 1/2. So multiply by the reciprocal, the 2's will cancel, and we get the square root of 3. Now, we know that it's that, but we have to put in that negative sign because it was the negative of that answer. So it'll be negative square root of 3. All right, let's look at 19 pi. See the sine of 19 pi over 4. So, how many times does 4 go into 19? Well, it goes in 4 times. That'll be 4 times 4 would get us to 16. So, we know that this would be 4 pi plus, there would be 3 left over because 19 minus 16 will get us 3 pi over 4. And 4 pi times 4 would get you that 16. So 19 pi minus 16 pi would get you 3 pi left over. All right, so now all we have to do, think about this. So this would be 1 pi, 2 pi, 2 pi. So then this would be 4 pi. So it's twice around, so we can still just use our 3 pi over 4, which would land over here. So our reference number will just be pi over 4 because that's what it takes to get back to the closest x-axis. So if we're looking at our reference value being pi over 4. And we know that we're landing in quadrant 2, because that's where we ended up at when we were using our unit circle to find it. So the terminal point will be square root of 2 over 2, square root of 2 over 2, but because it's in quadrant 2, this will be negative. So we know that the sine of 19 pi over 4 is equal to the sine of 3 pi over 4, because it's going to land in that spot, so it is the same as 3 pi over 4. And 3 pi over 4 would be equal to the sine of pi over 4. So if we look at this, pi over 4 and 3 pi over 4, you're like, but they're not exactly the same, but the sine values are the y values, and they are equal. If we were doing cosine, it would be the negative of it. But because we're doing sine, they're exactly the same, so it is equal to the sine of pi over 4. And the sine of pi over 4 would be the square root of 2 over 2. So again, it's all about making those connections. The more you connect with your unit circle, the more it will make sense. All right, so how would we find what if we want to find the sine of 1.5? Well, we're going to have to use a calculator for that, because that's not on our unit circle and it's nowhere near our unit circle. Oops. So we'll take our sine of 1.5, and that is not the right answer. If you notice here, we're up in degrees. We need to be in radians. So you need to go to mode and switch to radians, because we are doing radians right now. So now if we do our sine of 1.5, that's the answer we're looking for. So always make sure at the top here if you're in radians or if you're in degrees, at least on this calculator. So our answer would be equal to 0.9975. We'll go to 4 decimal places. Same thing would happen if we want to find the sine of 2.2. So we'll put in our sine of 2.2, and we get 0.85. So 0.8085. And we could also do cosine values this way. Cosine, let's do 1.1. So our cosine of 1.1 would be 0.4536. Alrighty. So we're figuring out some of the things that we can do. So let's look at cotangent of 28. So there isn't a cotangent button on our calculator. As you see, we only have sine, cosine, and tangent. So understand that cotangent is the reciprocal of 1 over tangent of 28. So we can use our knowledge of what's going on with our deal. Let's go look at the reciprocal identities. So cosecant, we knew was 1 over sine because it was 1 over y. Secant is 1 over cosine because it was 1 over x. Tangent is sine over cosine, and cotangent is cosine over sine. Cotangent can also be 1 over tangent because you would, instead of dividing by sine over cosine, you'd multiply by the reciprocal. So that's where it can also be 1 over tangent. So in a calculator, you need to know that because we don't have any of those buttons. We only have sine, cosine, and tangent. So we can put that in our calculator, and we can do 1 divided by the tangent of 28, and we end up with negative 3.5533. So negative 3.5533. So it's good to understand how to do these. Let's do one more of these. The cosecant of 0.98. Well, that would be cosecant goes with sine, so 1 over the sine of 0.98. Let me put the 0 so it's obvious. And so we would take 1 divided by the sine of 0.98, and that gets us 1.2041. 1.2041 for our answer. Alrighty, so we have some even and odd functions. Let's understand about those. So we've learned about them in college algebra, even and odd functions. And we're going to see some of these happening here. So sine, cosecant, tangent, and cotangent are odd. Cosine and secant are even. So the ones that just deal with x, they will be even. This is important to know because of what happens. If you take the sine of negative t, it will be equal to negative sine of t. Cosecant of negative t equals the negative of cosecant of t. But with cosine, it just becomes cosine, and secant, it's just secant. But tangent and cotangent will also end up with a negative out there. That's what you need to understand. So whenever you're dealing with even functions, these are the only two. The rest of them are odd, but it's good information to understand so that you can use that in order to figure out what your signs are. Not the sign as in the sign, but as in the SIGN signs. So if we're looking at our even and odd, if we have that sine of negative t, it would be equal to negative y, which is the negative of sine of t. But on that cosine of negative t, it's just equal to x, which is your cosine. And I'm writing this out so you can see the x and y, so you're still making some connections. So the tangent of negative t is negative y over x. So it'll still be the negative of tangent t because you have a y in there, but the x won't keep the sign. So if we're looking at the sine of negative pi over 6, that's equal to the negative of sine of pi over 6. And if we remember our reference, our terminal point for this, our terminal point is going to be the square root of 3 over 2, 1/2 for pi over 6. So it's going to be equal to 1/2, and it'll get that negative sign. And this makes sense because if we do negative pi over 6, that's going down into our quadrant 4. So if we go down into quadrant 4 for negative pi over 6 part, our y's are negative down here. So some of it you can kind of make some connections. All right, so if we look at the cosine of negative pi over 4, that's going to be equal to cosine of pi over 4. And pi over 4, our terminal point is square root of 2 over 2, square root of 2 over 2. So it'll be equal to the square root of 2 over 2 because it's an even function. All right, so now we're going to get into some trig identities. So if you remember, our unit circle was x squared plus y squared equal to 1 when it is the unit circle and it's centered at the origin. Well, from this, we get some Pythagorean identities. So we know that x is the same thing as cosine. So cosine squared t plus sine squared t is equal to 1. Well, we can rewrite this in a slightly different order because addition doesn't change anything. So sine squared t plus cosine squared t is equal to 1. That is our first Pythagorean identity. Identities mean they are just true. All right. Now, if we take our sine squared t plus our cosine squared t equal to 1, and we divide each of these by cosine squared t. Well, sine squared over cosine squared, let's rewrite this slightly. We can write it as sine t over cosine t quantity squared. Cosine squared over cosine squared, well, that's just equal to 1. And 1 over cosine squared, well, that's like 1 over cosine. That would be secant. So this will be equal to secant squared t. Well, sine over cosine we know to be tangent. So tangent squared t plus 1 is equal to secant squared t. Well, we know that value is going to be, or this identity, that is our second identity. So all we did was take sine plus cosine, both of them squared, equal to 1, divide them by cosine squared. Now what we're going to do is very similar. So we're going to take our sine squared t plus cosine squared t equal to 1, and let's divide both equations by sine squared this time. So we're doing the same thing, except this time we'll do sine squared. Well, sine squared over sine squared, that's equal to 1. And cosine squared over sine squared, let's rewrite this just a little bit to see what we're seeing here. That's cosine over sine. And 1 over sine squared, well, that's going to be cosecant squared. Well, cosine over sine, that's cotangent. And that's going to be equal to cosecant squared t. So you only need to know that first identity of sine squared plus cosine squared t equal to 1 because you can just divide by cosine and sine to get the other two. So that's a really cool thing about that, is just dividing by cosine and sine, we get to where we need to be. All right, so the next thing we're going to look at is looking at some of those using our identities here, and we are going to find all of the trig functions for a value of 1. So let's find all trig functions. And how many trig functions are there? That's right, there are 6. So find all trig functions from the value of 1. And we're remembering that there are 6 of them. So if we are given that cosine t is equal to 3 over 5, and we are told that t is in quadrant 4. Now, why do we need to know the quadrant? We need to know that because the quadrant tells us whether things are positive or negative. So in quadrant 4, we know that cosine is positive, but we'll know that anything with y will be negative. So we're going to use our Pythagorean identity of sine squared t plus cosine squared t is equal to 1. We don't know what sine is, but we know what cosine is. So sine squared t plus 3/5 squared is equal to 1. So sine squared t, 3 squared is 9, 5 squared is 25. And now we're going to subtract that over. And understand that this is equal to 25 over 25. We can write 1 any way we need it to be. So now we have sine squared t is equal to 25 minus 9 would get us 16 over 25. Taking the square root of both sides, we get that sine t is equal to plus or minus, so this is the square root of 16 over the square root of 25. Square root of 16 is 4, square root of 25 is 5. So plus or minus 4/5. So which one is it? Well, we go back to our quadrant 4, and we know that sine will be negative. So that tells us that sine t is equal to negative 4/5. Now from there, we can figure out the other trig functions. So we already know that we have our sine t right here, and we were given our cosine t. Remember, our cosine t was equal to 3/5. So that helps us find the other ones. So cosecant t is a reciprocal identity of 1 over sine t. So that'll be 1 over negative 4/5. Don't divide by fractions, multiply by the reciprocal. We end up with negative 5 over 4. And then our secant t is 1 over cosine t, which would be 1 over 3/5. Don't divide by fractions, multiply by the reciprocal, we get 5/3. Now for tangent, tangent t is equal to sine t over cosine t. So we get the sine of negative 4/5 divided by the cosine of 3/5. So that gets us negative 4/5 times 5 over 3. The 5's cancel, we get negative 4/3. And then the cotangent t, we can find this one of two ways. We can either put the x over the y, or cosine over sine, or we can say that it's 1 over tangent. So we can say this one is 1 over tangent t, so it would be 1 over negative 4/3, which would become negative 3/4. Or we could do cosine t over sine t, which would get us 3/5 divided by negative 4/5. So it'll be 3/5 times our 5 over 4, the negative, and we end up with negative 3/4. Either way works. You need to know how to do it both ways depending on what's happening with your problem. Alrighty, the next thing we're going to do is write one trig function in terms of another. This is an important skill to learn because when we get down to identities, you're going to have to be able to do this. So write one trig function in terms of another. So we want to write tangent t in terms of cosine t. And we are told that t is in quadrant 3. So tangent t is equal to sine t over cosine t. We need to write it all in terms of cosine. So we've got to turn sine in cosine, or sine into cosine, because we want it all in cosine. So let's go do our Pythagorean identity. Sine squared t plus cosine squared t is equal to 1. I've got to solve for sine in terms of cosine. So I'm going to move my cosine squared t over. So sine squared t is equal to 1 minus cosine squared t. Take the square root of both sides, and we have sine t is equal to plus or minus the square root of 1 minus cosine squared t. Now, which one is it? Quadrant 3. Quadrant 3 tells us that both sine and cosine are negative, and because we're solving for sine in terms of our cosine, it will be equal to the negative of 1 minus cosine squared t. Now we've got sine in terms of cosine, so our tangent t, which was equal to sine t divided by cosine t, is now equal to the negative of the square root of 1 minus cosine squared t over cosine t. You need to be able to do this problem. Here's a wink, wink, nudge, nudge for exam 1.